Hi, my name is Jen Liu, and today I will be talking about the paper that I co-authored with Phoebe Sengers titled Legibility and the Legacy of Racialized Dispossession in Digital Agriculture. So our paper focuses on digital agriculture systems, which we are defining as network systems that are designed, developed, and deployed in the agriculture industry. These systems are designed to address various social and economic and environmental challenges in food production. In our paper, we conducted an historical analysis and ethnographic analysis to understand what is shaping this technology. We built on the work of HCI, CSCW, and information studies scholars in this area who are examining questions of labor not just in agriculture, but in a wide variety of work settings. Our paper contributes to this literature by examining the issues emerging from the confluence of digital systems of control and historical systems of the control of land, living beings, and labor at work in agriculture in the United States. We developed legibility as a concept, drawing primarily from James Scott's work on scientific forestry as a system of governance that uses simplified understandings to control and direct action upon it. This work has been influential in other recent work in HCI and CSCW, such as Ali Al-Khatib's work describing how algorithmic systems incorporate bureaucratic tendencies which can lead to absurd outcomes. In our case, legibility is a feature of data-driven agricultural technology. In digital agriculture, legibility is seen as a tool for creating responsive approaches to farming that is promised to allow farming to be sustainable and productive at scale. Rather than simply mechanically applying water, fertilizers, or other interventions, these systems have the potential to predict and respond to environmental conditions and needs that arise dynamically. In our fieldwork, we conducted interviews and participant observation in upstate New York throughout 2019. At a few of our sites, we saw the use of Normalized Difference Vegetation Index, or NDVI sensors, which use infrared light to determine plant health. This data is then incorporated into automated applications of certain materials such as fertilizers or pesticides. However, in order to collect accurate data in the first place, the fields must be made legible, such as having straight and evenly spaced rows to account for the machinery and equipment to take readings. This is much like Scott's account of scientific forestry, where there is a need to simplify the landscape itself in order to render it legible to digital systems. But why does the landscape even look like this in the first place? We turn to this historical analysis because as we were conducting our fieldwork, the racial stratification of agriculture work was apparent in who we spoke to and the racialized interactions we had throughout the fieldwork. According to the USDA census, 98% of farmland is owned by white operators. In New York State, this number goes up to over 99%. Well, agriculture was not always so white. At the beginning of the 20th century, Black farmers accounted for 14% of all U.S. farmers. However, this number dropped off over the course of the century. Historian Pete Daniel documents how between 1940 to 1974, there was a 93% drop of Black farmers. This is puzzling due to the overlap that during this time period has with the civil rights movement. However, Daniel argues that due to racial discrimination at the federal level, this created barriers for Black farmers from accessing loans and insurance for capital-intensive agriculture. But where do we really start? How do we understand land possession in the first place? We see this as an important narrative to include when we talk about digital agriculture, as indigenous peoples created the first food systems on the land that is now known as the United States. European settlers used the doctrine of discovery to make claims of land, using concepts such as terra nullius as a justification to clear existing people and ecologies as a prerequisite for settler forms of agriculture. Taking this into account, we can expand our understanding of legibility as tactics for control of labor and nature that has been in the US since the start. So how does legibility get built into agricultural technology? In our paper, we draw attention to a moment of US history where we see the failure of Reconstruction and the rise of scientific agriculture as playing a key role to addressing this question. In conjunction with the attempted genocide of indigenous peoples, the United States was also built on the labor of enslaved Africans. After the American Civil War in 1865, Reconstruction was attempted to provide reparations to newly freed slaves. For example, Special Order No. 15 was issued to provide 40 acres and a mule to former slaves, drawing from settler colonial notions of land distribution as a premise for building wealth. However, Reconstruction ultimately failed as we see the rise of the Jim Crow era, notably in the American South, but also prevalent throughout much of the US. During the same period, we also see the rise of scientific agriculture as an attempt to make farming more productive and less laborious, which is not necessarily a bad thing. What we do see, though, is how legibility is amenable to development of certain agricultural technologies where mechanized and automated systems use simplified understandings for control and action. Scientific agriculture became adopted by federal institutions in addition to forms of agriculture that could be mechanized at scale. However, these federal institutions, as previously described by Daniel, had discriminatory practices against Black farmers and other farmers of color. For example, while institutions like the USDA invested in mechanization, this funding was prioritized to white farmers to allow them to let fields lay fallow in order to improve technology on their farms. This point is important because it shows who is allowed to be a manager of such legibility. So what does legibility look like in digital agriculture? We return to our sensor, where the NDVI sensor is not getting a proper reading, which necessitates straighter fields and tighter forms of control. However, that is not the end of the story. What our understanding from this historical analysis shows us is how the spatial configuration of farm and farmland is not neutral, that these spaces exist because of specific ways of thinking about the environment and how the world should be oriented. Digital agriculture systems inherit and build on these existing practices of agricultural mechanization as a prerequisite for proper data collection. To conclude, while digital agriculture may seem new, the settler, colonial, and racialized visions built into these systems are not. Agendas for digital agriculture and other forms of data-driven systems need to account for how it impacts not only labor relations, but relations with land and other ecologies. However, what this looks like in practice is tricky. For example, participatory design practices can be limited in who can be included if certain people have been systematically removed from the land for generations. Ultimately, we offer in this paper a way of examining how digital systems can inadvertently uphold legacies of oppression. As work in CSCW begins and continues to work towards liberatory practices, we must chart out new pathways for technologies based on a sharpened understanding of how these systems came to be in the first place. Thank you for listening to me today, and if you want to hear more, please check out the paper I co-authored with Phoebe Sengers titled Legibility and the Legacy of Racialized Dispossession in Digital Agriculture. Thank you.